Okay, so hi everyone, Senan this side, and in this video we are going to solve combination sum 3. We just solved combination sum 1 and 2 just before this video. So I would highly suggest you to at least solve this or check those videos out. So that is very much important. Okay, so what is this question asking is find all valid combinations of k numbers such that the sum of n sum up to n. Okay, so these k numbers sum up to n such that the following conditions are true. Only numbers 1 to 9 are used. Each number is used at most once. Return a list of all possible valid combination. List must not contain the same combination twice, and the combination may be returned in any order. Okay, so let's look at one of the test cases. So if n is 7, we need 3 elements such that their sum is 7. So 1 plus 2 plus 4 is what? 7. So that is true, and that is the only possible triplet that when gone through these constraints it would be satisfied. For k is equal to 3, n is 9, you can see 1, 2, 6, 1, 3, 5, 2, 3, 4, everything sums up to 9. And these are the only 3 valid combinations. Okay, so that is great. For k is equal to 4, n is equal to 1, you cannot actually get this because if you take any 4 elements from 1 to n, at least they would sum up to 10, right? Or yeah, so 1 plus 2 plus 3 plus 4, they would sum up to 10. And so in no possible case you can get n is equal to 1. Fine, that is great. So basically I would highly suggest you to watch combination sum 2 because that is the same logic we are going to use in this video. If you've seen this video, you've seen this basic structure. We did this for combination sum 1 and 2. Now in combination sum 2 we had a candidates array, right, which stored some values and they could be repeated, they could not be repeated, all those things, right? Now in this question I would do is assume that I have the same candidates array, right, and the elements of that candidates arrays are from 1 to 9 and there are no repeated elements. So I would solve this using the same logic. A hypothetical array is in consideration. So basically you have the answer for returning the final answer. You have a temporary array to store the current possible solution, right? And then you call this recursive solution starting from 1 n k l. Let's see what this is all about. So com sum 3 int I target max depth temp and answer. So temp and answer, you know, temp is for storing your current answer is for storing all possible answers that you found till now, and the max depth is basically the maximum number of elements that this temp, or exactly the amount or exactly the number of elements that you require to get to the sum temp. Also you need a target and the index I or the element I. In this case everything is same. Okay, so I might have erased that. So this is the code. So what is happening is, let's look at the base case later on. Initially what I do is, what does this mean basically? So starting from 1 to 9, in how many ways can I basically get to this target value, right? That is what this question is asking. So I'll start from j is equal to I to j is less than 10 because we know the last number can possibly at most, at max basically 9. So what I do is assume, let's say j is, I'll discuss this break later on. Let's assume that j is a part of my combination sum, right? Now if that is the case, what I do is I say j plus 1 target minus j max depth temp and answer. What does this mean? From j plus 1th index till the end, can you find a combination sum of target minus j, right? And the same max depth, the same temp and the same answer, right? That everything is basically same. So maybe you could decrement max depth whenever you push an element inside, but let's do it this way that I'm showing you. So that is happening. Now let's compare this with combination sum 2. In that we had this break statement. What this break did is, since my target is less than j, so any number at j or after j cannot be a part of my combination sum because that would break the condition of it reaching to the target, because target and both n and k are both positive, right? So a negative value of this target can never be achieved. So if that becomes the case, I just break out of the loop. I don't even check that. So the next thing is, we had another if statement to check if there are duplicate elements, right? In this case we are assuming that our candidates array has exactly elements from 1 to 9 and everything is unique, right? They are in the sorted order. So that is why we are not going to use that if statement, if you remember what we did last time. Now let's discuss the base case. If for some reason we get to temp.size is equal to max depth, we check if target is 0 or not. For some reason we just push the elements into the array and we update the target. If target is 0, that means we have found a solution, possible solution, and the length of this temporary array is actually equal to the max depth. So in that case, that must be the case when the temp is a part of our answer, so I push back that answer, right? Otherwise I just return. Now if you remember, how does this take case of uniqueness? So the same logic as we used in combinations. Now you see, this is working fine. This was easily accepted, and even if you see, it beats 100%. I cannot ask for anything more than this. So I hope you understood this. What is the time complexity? What is the space complexity? Space would be at max, the max depth, that is the maximum element I can show in the temp. I'm not considering the space of the answer. It could be dynamic. You can just possibly see or all possible solution that you could have from 1 to 9, like 4 choose 9. That's the worst case in worst space complexity while storing the answer, right? 4 choose 9 or 4C9, whatever. Oh, sorry, 9C4 or 9 choose 4. Sorry for my mistake. It's 9C4, 9 choose 4, whatever you call it, in the worst possible case. Although that won't be the case, definitely. And what is the time complexity? You call this for, you call, if you discuss the time complexity, so the recursive function would be t of n is equal to, let's say we are traversing I to n, I to 10, so at max 10 times the worst case, or basically 9 times, right? 1 to 9, so 9 times t of n minus 1. And since we know the size of n is exactly 10, so this is what is t of 10, which is somewhere about 9 factorial. This is somewhere about 9 factorial. Basically you could, if you see, you could treat this as a, because you know the size of the answer, right? Obviously this is not constant, but in the worst case, if k is 9, so we can take all the elements, so the sum from 1 to 9 is what is 45, right? So that is the worst case, that we would look all the possible cases, but we won't get to a result. So that is why you see n is less than 60, because if you sum from 1 to 9, that would be, I think, 45, and after 45 there is no solution. So you can even do this if n is greater than 45, just return empty array. Okay, so I hope I made no mistakes. If I did, please tell me in the comment section. But anyways, that was the video. Hope you enjoyed this, and if you did, please share it with someone that you think might benefit from these videos. And anyways, thanks for watching. Bye.